Okay, here's a question where we're given y in terms of x, and the first thing we have to do is find dy by dx. So that's using the rule that you learned in chapter 5. You should know what you need to do with each power of x and what number pops out in front. So look up in chapter 5 if you've forgotten how to do that. In part B, we've got a point on that curve, and we need to show that the gradient at the cut point P is 5, so this 5 is your end point. I want to show that question. Your start point is the gradient. You should know that the gradient of the curve is exactly dy by dx, but you've got a particular point, so you've got a particular x value and a particular y value. In fact, it's just the x value and your answer to A that you need in order to get the gradient, and you know the answer you should get is 5. Here's a re-entry point. Even if you couldn't do any of the question up to this point, we now need an equation of the normal. That's a straight line. You've got a standard recipe from chapter 3 for straight lines. It begins y minus y1 equals. And all you need to feed into that recipe are a point and a gradient. Now we've already got the point P, and we've got a gradient of 5 from the previous part. We need to make sure that that's the correct gradient for the normal. So are you going to use that 5, or do you need to do something to it to get the gradient of the normal? Then use your standard recipe and look, get your answer into this form. A, B and C are integers. That means they have to be whole numbers. And then finally in part C, we've got a question about being increasing or decreasing. That harks back to part A. dy by dx is what you need to look at for a particular x value you substitute in, and you can interpret the answer as increasing or decreasing. If you've forgotten how to do that, then your notes from chapter 6 will show you how. And chapter 6 has also got worked examples of finding normals to curves. Hope that helps.